Hello and welcome to SigmaXL video tutorials. In this video, we demonstrate general linear model and measurement systems analysis templates found in SigmaXL. General linear model extends advanced multiple regression to include support for fixed and random factors and nested factors. Fixed versus random factors. A fixed factor includes data for all levels of interest. For example, there are only 2 test machines in a plant. A random factor has levels that are randomly sampled from a larger number of possible levels, but interest is in all possible levels. Gauge repeatability and reproducibility studies typically assume that part and operator are random factors, or random or mixed random fixed factors with a balanced design. The ANOVA invariance components, or VC report, is given based on expected mean squares. VC confidence intervals using restricted maximum likelihood REML are included. For details on statistical models, formulas, and references, see the appendix of the SigmaXL workbook. Cross versus nested. Classical Gage R&R studies are crossed, where each operator tests each part multiple times. An operator by part interaction may be calculated. Nested Gage R&R studies have each operator testing unique parts. This is typically a destructive Gage R&R. An operator by part interaction cannot be calculated. Nesting. In SigmaXL, check nesting to include nested terms in the model. The left side combo drop-down selection can be a factor or covariate. The right side drop-down selection is a factor. This will create a term with the notation A parenthesis B, where A is nested in B. Another example of a nested term would be operator nested in location, where the operators in each plant location are different. This video focuses on case study examples using GLM to demonstrate the analysis of sources of variation, destructive nested Gage R&R, and expanded Gage R&R. For our first example, the sources of variation study, we'll first use multivariate charts to take a look at the dominant sources of variation, or SOV, of 3 major families of variation: within unit, between unit, and temporal, or over time. Knowing which source of variation is dominant will help us to prioritize our efforts to reduce variation. We'll be using the sample data set called multivariedata.xlsx. Click Sheet within. Click SigmaXL, Graphical Tools, Multivariate Charts. Select Measurement and click Numeric Response Y. Click Unit and click Group Category X1. Click Time and click Group Category X2. Click OK. The resulting multivariate chart demonstrates dominant within unit variation. Repeating this analysis for sheets between as well as over time produces the following results, where we can clearly see what source of variation is dominant. Now we will reanalyze the multivariate data using general linear model. Unit and time are random factors, and unit is nested within time. The variance components will be calculated to quantify the percent contribution to the total variation for each factor. Click Sheet within. Click SigmaXL, Statistical Tools, General Linear Model, Fit General Linear Model. Select Measurement and click Numeric Response Y. Select Time and click Random Factors Categorical X. Click Unit and click Random Factors Categorical X. Check Nesting. For the left side drop-down, select a factor or covariate. Select Unit. For the right side drop-down, select a factor to nest in. Select Time. We'll use the default coding for categorical factors -1, 0, +1, and default confidence level of 95%. Leave residual plots, main effects plots, interaction plots, and Box-Cox transformation unchecked. Note that advanced options are not available with random factors. Click Next. Ensure term generators set to main effects. Click Select All. The term unit parentheses time denotes that unit is nested in time. Since time is the top level of the nesting, we place it in the model first. Click OK. A variance components report is generated. The error term in the variance components table is the within unit variation. It is contributing to 100% of the total variation. The REML 95% confidence interval for this variance component is also given. The terms time and unit nested in time have negative variance component values, so are treated as 0. The ANOVA table shows that both terms are not significant random factors with an alpha equal to 0.05. Standard deviation components are provided for convenience and useful in measurement systems analysis, but they will not be discussed here. The GLM model sheet is the regression analysis, but we will not review that here as our focus is on the variance components analysis. Now, click Sheet Between. Repeat the previous steps to produce the variance components report. Here, we see the unit time term in the variance components table is the between unit variation. It is contributing to 98.3% of the total variation. The within unit error term is contributing to 1.7% of the total variation. The 95% confidence intervals for these variance components are also given. The term time has a negative variance component value, so again is treated as 0. The ANOVA table shows that time is not a significant random factor, but unit nested in time is significant. Now, click Sheet over Time and repeat the previous steps to produce the variance components report. The time term in the variance components table is the over time variation. It is contributing to 98.5% of the total variation. The between unit nested in time term is contributing to 0.6% of the total variation. The within unit error term is contributing to 0.9% of the total variation. The 95% confidence intervals for these variance components are also given. Note that the confidence interval for time is very wide. This is due to only having 3 levels. If possible, additional time value data should be collected in order to reduce the uncertainty of the variance component value. The ANOVA table shows that time and unit nested in time are significant random factors. For our second example, we will analyze data from a destructive nested Gage R&R published in the Journal of Mechanical Engineering. A link to this paper is provided in the SigmaXL workbook and the datasheet. This is a shear test for a resistance spot welding process. Design of experiments were used to produce the parts by varying preheat temperature, preheat current, welding temperature, and welding current. Each run of a 4-factor 8-run fractional factorial DOE is a part, and this was replicated 6 times for a total of 48 welds. 2 shear test machines were used, so each machine tested 8 parts with 3 replicates. The shear test machines are the operator and treated as a random factor in the study. Tensile shear strength, TSS newtons, and ultimate strain, USMM, were measured, but we will only consider the TSS here. Click SigmaXL, Statistical Tools, General Linear Model, Fit General Linear Model. Click Use Entire Data Table and click Next. Select TSS and click Numeric Response Y. Select Operator and click Random Factors Categorical X. Select Part and click Random Factors Categorical X. Check Nesting. For the left side drop-down, select a factor or covariate, select Part. For the right side drop-down, select a factor to nest in, select Operator. We will use the default coding for categorical factors, -1, 0, +1, and default confidence level of 95%. Leave residual plots, main effects plots, interaction plots, and Box-Cox transformation unchecked. Click Next. Leave term generator as main effects. Click Select All. The term part with operator in parentheses denotes that part is nested within operator. Since operator is the top level of the nesting, we place it in the model first. Click OK. The variance components report is generated. Note that operator is a negative variance component. It will be treated as 0. Now we will convert the GLM variance components to Gage R&R metrics using SigmaXL's GLM Gage R&R template. Click Measurement Systems Analysis, Basic MSA Templates, GLM, Gage R&R, Nested Metrics to open the conversion template. Copy the variance component values in cells C18 to C20. And paste the values into the yellow highlighted cells at C15 and C17 of the template. Use standard deviation multiplier equals 6. It's crucial to ensure that the GLM variance component's source names match those given in the template. If the GLM model order was different than that of the template, each entry would have to be copy and pasted individually. This template converts the GLM variance components to Gage R&R metrics. With percent total variation less than 30% but greater than 10%, this is a marginal measurement system. The results match those given in the paper. For our third and final example, expanded Gage R&R, we will analyze data from a paper titled A Study of Gage R&R Analysis Considering the Variations of Between Within Group and Within Part. This is a wafer thickness measurement, angstroms, for a semiconductor process. The design includes random factors: batch, wafer, location, and operator. Wafer is nested within batch, and location is nested within wafer. There are 3 batches, 3 wafers, 4 locations, 3 operators, 2 replicates for a total of 216 thickness measurements. The variance components for part process include batch, wafer nested in batch, and location, nested in wafer, nested in batch. The variance components for reproducibility include operator, batch by operator, wafer nested in batch by operator, and location nested in wafer, nested in batch by operator. The variance component for repeatability is the error term from replicates. Open the file waferthickness.xlsx. Click SigmaXL, Statistical Tools, General Linear Model, Fit General Linear Model. Click Next. Select Thickness. Click Numeric Response Y. Select Batch to Operator. Click Random Factors, Categorical X. Check Nesting. For the left side drop-down, select a factor or covariate, select Wafer. For the right side drop-down, select a factor to nest in, select Batch. For the second left side drop-down, select Location. For the right side drop-down, select Wafer. We will use the default coding for categorical factors -1, 0, +1, and default confidence level equals 95%. Leave residual plots, main effects plots, interaction plots, and Box-Cox transformation unchecked. Click Next. Using Term Generator, select Main Effects plus 2A Interactions. Click Select All. The term wafer (batch) denotes that wafer is nested within batch. The term location (wafer) (batch) denotes that location is nested within wafer, which is then nested within batch. Only legal two-way interactions are available, so wafer by batch, location by wafer, or location by batch are not available. Click OK. The variance components report is provided. Note that the variance components confidence intervals for the interaction terms with operator are very wide, and the p-values are insignificant, so the model could be refit excluding these terms, but for the purposes of this video, we will not do so. We will now convert the GLM variance components to Gage R&R metrics. Click Measurement Systems Analysis, Basic MSA Templates, GLM Gage R&R Expanded Metrics to open the conversion template. Copy the variance component values in sheet GLM1 varcomp and paste the values into the yellow highlighted cells of the template, starting with the variance value for error. Next, select the 3 first source components and paste them in the part process source fields. Finally, copy the remaining reproducibility components that contain operator and paste them into the operator measurement source fields. Use standard deviation multiplier equals 6. This template converts the GLM variance components to Gage R&R metrics. With percent total variation equal to 10%, this is an acceptable measurement system. The results match those given in the paper. This concludes the tutorial video for General Linear Model and MSA Templates. For more videos, visit www.sigmaxl.com or join us on YouTube. Thank you for watching.